Today we are going to be covering section 4.4, which are scatter plots. We are going to be working with different scatter plots, but before we actually start, let's go and listen to an introduction video, and then we'll come back to the notes.
How do you figure out if doing more homework means getting a higher test grade? In this lesson, you will learn how to construct a scatter plot by graphing data. Let's review. When graphing on a coordinate plane, we have a horizontal axis, which is the x-axis, and we have a vertical axis, which is the y-axis. When graphing a point, we must remember that the first number is your x-coordinate and the second number is your y-coordinate. So for instance, if we want to graph the coordinate pair 2, 3, we would go to the right 2 and then up 3. If we wanted to graph the point 4, 1, we would go to the right 4 and up 1. And if we wanted to graph the point 7, 8, we would go to the right 7 and up 8. A common mistake when working with bivariate data on a coordinate plane is getting caught up on which piece of data is on which axis. As long as you are consistent with labeling your axis and consistent with putting the correct data on the right axis, it doesn't matter. A 3, 4 would be the same as a 4, 3. Have you ever wondered if there was a relationship between homework completed and your test grade? We can find out by taking a survey to see if these two things are related. Data that may be related are gathered in pairs. This is called bivariate data. For example, if I were going to examine the possible relationship between the number of homework assignments completed out of 10 that were assigned before a test and the grade that the student got on that particular test, each person in the survey or the sample would produce a pair of numbers. One for the number of homework assignments completed and one for the test grade. So let's take a survey. Here, we have talked to a group of students and asked each student how many homework assignments they completed out of the 10 that were assigned and what they made on their test grade. This is just a sample of what we collected. We can see that John completed 5 out of the 10 homework assignments and made a 70 on his test. So now we've collected this data. We have a nice table. Now what can we do with it? We can create a scatter plot. A scatter plot is a graph of points on a coordinate grid with each axis representing one of the two variables. In other words, it gives us a nice picture of the data that we collected, and we can look at the picture and determine if there is a relationship between the two pieces of data that we collected. So let's make a scatter plot for this data that we've collected from the students concerning the homework assignments completed and their test grade. The first thing we're going to do is label our axis and determine our scale. The scale will be different depending on the type of data we're collecting. Since the number of assignments ranges from 0 to 10, we will count by ones on the x-axis. Since the test score can be up to 100, we're going to count by tens on the y-axis. Here, we have plotted the points represented in our table. Let's see how we got a few of them. The first student did 5 homework assignments and made a 70 on their test, resulting in this point. While the second student only did 2 homework assignments and made a 25 on their test. And that resulted in this point. So now let's just look at the graph. We notice that as the number of homework assignments completed increases, so does the test score. So we can make a general statement that as the number of homework assignments completed increases, the test grade increases. We have constructed a scatter plot by graphing data, and we can draw a conclusion based on this scatter plot. We can say, yes, doing more homework means getting a higher test grade. In this lesson, you have learned how to construct a scatter plot by graphing data. How do you figure out if doing more homework means getting?
Yes, we're not going to listen to that once again. But let's go and start our lesson. So you guys have learned an introduction to scatterplots, and basically a scatterplot is a set of points on data that people have collected or that you have collected. And we are going to plot points on a horizontal and vertical axis, on your x-axis and your y-axis, in order to attempt to show how much one variable will be affected by another. So in this case, how much is your age correlates to your height. And they're going to be using the word correlation. Correlation is a very easy thing to understand. It's going to be a way of measuring how closely related two sets of paired data are one to another. We can have a positive correlation if your data points are going up. It's going to be a negative correlation if your data points are going down, just like positive slope and negative slope. And there are times that you find no correlation, that the data doesn't tell you anything. It's all over the place. On today's problems, we are going to be giving you guys a data plot. And the only thing that you have to do is answer the questions that are given. So the chart, example number 1, the chart shows the average daily temperature and the amount of visitors at a beach resort. Make sure that you look at the data plot first. So we have our average daily temperature on the x-axis and the number of visitors on the y-axis. And just like the video shows you, that sometimes and many times it's not going to go by 1. So notice that it starts at 75 and then 75 more is 150 plus 75 plus 75 plus 75 in order to be able to graph all the points. And notice that your x-axis is from 80 to 84. That means that this is 80, this is 82, 84, 86, 88. And if you guys see this little squiggly line, tells you that there's 0 to 80 is right there in between. And since we didn't have any results, we can skip that section. Now let's go through letter A. How many visitors attended when the temperature was 92? So the temperature was 92 is here. I'm going to go up. I'm going to see which point I encounter, which is this one here. And I'm going to go to the left. So therefore, there were 450 visitors. 450 visitors attended. How many visitors are expected when the temperature is 90 degrees? So see if you can answer that question yourself. 90 degrees. So yes, 88, 90 degrees is here. And if I go up, notice that there's no points on this line. And that's what they're asking you, how many are expected. So even though we didn't find a point, if you can imagine a line that goes through most of the points, it probably will be around here as well. Now if you give me this point, this point, this point, or this point, that should be fine. In this case, if 90, I'm going to select this point, even though there's none, and there'll be also 450 visitors. Expected. So data plot allows you to make estimations based on the data that you've collected. What does the data tell you? So we look at the x-axis. What happens as the temperature increases? So if you notice, as the temperature increases, the dots are going higher. So that means that you get more visitors. As the daily temperature increases, the number of visitors increases as well. And when they ask you to interpret the data, or what does the data tell you, you want to be able to form one sentence based on your x to your y-axis. And I usually use the word that's given to me. So as the daily temperature increases, what's happening to the visitors? The number of visitors also increase. And I want to be able to see those two lines, one for your x-axis and one for your y-axis. Find the equation of the line from the points 8422 and 9600. So we have 84, 225 is this one here, and 94 and 600 is up here. So therefore I'm going to use my ID to connect them. And notice that it crosses at 0. So first, I'm going to find my slope. To be able to find the equation of the line, I'm going to find my slope. M is equal to, I'm going to subtract the y's. So it'll be 225 minus 600 over 84 minus 94. So the denominator will be easier to do. 84 minus 94 will be negative 10. 225 minus 600, I'm going to go and subtract them. I'm going to subtract them on the left. That'll be 600 minus 225. Remember, the bigger number minus the smaller. So I can 0 minus 5 I can't. 0 minus 2 I can't. So I'm going to borrow 1 from the 6, makes it a 5, a 10. I'm going to borrow 1 from the 10, makes it into a 9, and that's a 10. So 10 minus 5 gives me 5. 9 minus 2 is 7. 5 minus 2 is 3. So it'll be 375. Keep the sign of the bigger number, so it'll be negative. Negative divided by negative is going to be a positive, so it'll be 375 divided by 10. This is my slope. Now, in order to be able to find my equation, I need to be able to find my b. My b is my y-intercept. In this case, will be 0. And I'm going to use my equation y equal to mx plus b. Now, your equation is going to be a bit messy because you're going to end up with a fraction. Or you can change it to a decimal. 375 divided by 10 will be 37.5. Or we can reduce it. But right now, since we're not using a calculator, we can leave it as that. 375 over 10 x plus b, which is 0. Remember, b is your y-intercept. Let's go over to example number 2. Answer the following question with a given scatter plot. So one of the things that you want to make sure that you do is that you analyze the scatter plot first. So on your x-axis is the number of study. How much time do you spend studying? And your y-axis will be your test score. What does the data tell us? Remember, whenever they ask you for what does the data tell us, we are going to be analyzing your x-axis to your y-axis. So we're going to say, as the number of hours of study, as the hours of study increases, the test scores what happens to the test scores? So as the number of studies increases, your test scores also increase. And once again, I want to be able to see two lines, one with your x-axis and one with the y-axis. And now we can answer the following question. If Olivia spent 6 hours of studying, what will you predict her test scores to be? So 6 hours, we can expect our test scores to be around here, which will be about 82%. So we can say Olivia's test scores is expected to be 82%. Find the equation of the line that form the points 162 and 897. So 162 and 8 and 97. I'm going to connect those 2 points. And I'm going to find the slope. Now to find the slope will be the difference of the y's over the difference of the x's. That'll be 62 minus 97 over 1 minus 8. And now I can subtract 1 minus 8 will be negative 7 on the denominator. I'm going to subtract the bigger number minus the smaller one on the left hand side. 7 minus 2 is 5. That gives me 3. And keep the sign of the bigger number. Will be negative. 35 divided by 7 is 5. So it'll be positive 5. Now that I have my slope to be 5, I need to find my b, my y-intercept. And in this case, we're going to have to estimate. Because it doesn't go directly into 55, we're going to say that's 56 or 57. 56 should be fine. So b will be 56. And now we can use a point slope or slope-intercept form to find the equation. So it'll be 5x plus 56. That'll be the equation of that line. Let's try example number 3. The chart shows the amount of rainfall in Tennessee from 1999 to 2009. So we have on your x-axis, we have the year. And on the y-axis, we have the rainfall. And now we can answer the question. So give me a second.
A higher test grade.
How much rain did it fall in 2001? So now we're going to go over to 2001. And how much rain did it fall is right here. So we can go to the left and we have 50 centimeters of rain. Estimate the amount of rain in 2009. So notice that in 2009, we don't have a data point, but we can estimate if we can visualize a line. So anywhere around here, so if you want to place it up here is fine, if you place it down there is fine. We are estimating. So in this case, for our purposes, I'm going to place it right here, over on the left. So even though there's no point in there, I'm just going to place it there. So therefore, 2009, we can estimate the rainfall to be 20 centimeters. And now find the equation of the line from the points 2001 and 52, 2001 and 52, which is right here. So notice that in this case it's supposed to be 52, but if we write down 50, it should be fine. And 2008 and 23. So I'm going to connect, using my idea, I'm going to connect both of the points. And I'm going to find the slope. So now that I connected both points with a line, I can find the slope. M is equal to your slope. So I'll circle the y's. It'll be the difference of the y's minus the difference of the x's. The x's. I'll be 52 minus 23. I'm going to work it out on the side. 52 minus 23. 2 minus 3 cancel, borrow 1 from the 5, we can say 4. And that gives me 12. 12 minus 3 will give me 9. 4 minus 2 will give me 2. It'll be 29. Keep the sign of the bigger number over 2001 minus 2008 will give me negative 7. This is a fraction, so we're just going to leave it as a fraction. So my slope will be negative 29 over 7. And notice that my slope is negative. And my b is my y-intercept. So in this case, it crosses the y-axis at 60. And now I can write out the equation of the line. Y is equal to negative 29 over 7, x plus 60. And the last problem. The following graph shows the number of miles athletes jog versus the average speed. And if you notice that in this case, your x's and y's are not labeled. So the following graph shows the number of miles athletes jogged. So we're going to write that down. The number of miles versus their average speed. So the y-axis will be their average speed. What's going on here? So you're going to label your x-axis to be the number of miles, in this case versus the average speed, so your y-axis is the average speed. And now, what does the graph show? If you notice, all the points are all over the place, so therefore we're going to say there's no correlation. It doesn't show us anything. There is no correlation. And that'll be the case at times when you collect data. That sometimes the data will be show you positive correlation, sometimes it'll be negative, but sometimes it doesn't show you anything. So there's nothing that correlates from one to another. So now work on your objective met, and then your homework, and this will be due the next time I'll see you guys. So everybody will be working on 2 simple problems from your objective met, and I'll collect your homework next time I see you guys. Have a great day.